Hey everybody, welcome back. We're going to be now doing a few lecture-heavy videos with some React demos, REST and React demos kind of sprinkled in. But the topic of this week is using the web as a distributed computing platform, which you see on the screen in front of you. Um, but the idea is that the web, with all of these heterogeneous systems kind of all interconnected, they can all provide different services. They can um, basically enable this incredibly powerful worldwide application engine, for lack of a better term. Now, I'm sure you've heard of distributed computing in various fashions or terms. You might have heard of it from, say, undergrad or even grad classes where you have some process and it's too big to do all at once. So you kind of chunk it up and send it off to other computers or other processes, and they work on bits and then they come to an answer later on and you get your solution. Or you might have heard of it kind of like disparate systems all working on their own things, kind of an agent-based type of system. And then they will work towards their goals, and then ideally, whatever answers they spit out helps the common good. Now, the idea here is that the web is basically just a massively interconnected network. That's all it really is, right? Every single system on this web is heterogeneous, meaning that it's different. Its hardware specs and software specs are different, but they can each provide a different service. And that long-winded intro is basically boiling down to, let's talk about RESTful computing and some of the competitors as well. Now, just as a full warning, um, I'm not really going to be doing any demos for W3C services or SOAP. I'll show you what it looks like, but it's too complicated, at least for me right now, to set up a demo that is not going to be worth it. Because pretty much everybody's moved to REST, at least, if you have a current gen system and you're not supporting something legacy. At least that's my take. If you want to see SOAP things, please let me know and we can figure something out. But kind of the goal is to go over some of the history, talk about what a service-oriented architecture is. We'll cover W3C, and then we'll go into RESTful, and then we'll talk about comparison and why one is over the other. So with this idea of a worldwide distributed network, the idea is that we're going to have some kind of a client-server setup. So it's a distributed client-server setup. And hopefully you're all aware by now, client-server. The server is some main processing entity that will serve up content to its clients, right? Client navigates to a particular server's address, sends a request, hey, I want your web page. Server understands that, packages it up, sends it back, right? So that's what we all know and love in this class so far. Interestingly, that is a very basic view of this idea of a client-server system. And with, again, everything being networked, the internet becoming so ingrained in our day-to-day lives, right? I've got, I think, Reddit comments blowing up on my phone here. Stuff's happening on Twitter, and I'm getting notifications all the time. Basically, it's pervasive, right? That means it's intertwined. How can we use that to our advantage? And I'm not saying Twitter and Reddit, that's just, I'm looking at my phone randomly lighting up while I'm talking here. So let's say we want to build a distributed client server system. You are at a startup, you are at a company, and you need to build some kind of a website for your insert company name here, where it's going to distribute the load. There's going to be more than one machine that's the server, and we're going to basically be kind of generating this big system for everybody to use. And kind of the goal here, which I should probably talk to as well, if we're going distributed, we're avoiding things like single points of failure, or we are trying to make as much use out of all of our devices as possible. So going back to our standard setup, you have a web server hosting content. Well, we might split that web server up. One machine's hosting content, another one's doing authentication, another one's getting the weather, another one is getting our payroll reports, another system is doing this, and we're all kind of bringing it together in this one cohesive application. That's kind of the idea with the distributed nature. Now, could one server do all that? Absolutely, it could, but usually it's better to split these things up. Again, single points of failure, redundancy, um, could even be a heavy processing load that we want to kind of spread out. That's usually the reason why you do something like this. So how do we do that? Well, the common solution, at least for the longest time, was let's just build it ourselves. Okay, let's set up some sort of a system where we develop this custom middleware where we're still going to have a server that presents data. We'll have all of our clients that access data. And then we have some kind of a cobbled together system that's going to handle all these service calls. It's going to go out and get our reports. It's going to go out and get leave. It's going to track hours. It'll do payroll, everything that we need it to do. All right, let's build it ourselves. Let's build a custom .NET application. We've got an intern raring to go. Let's get that done. Okay, that's fine, but it's very, very optimized for your environment. That could be good or bad, right? It is only ever going to work in this one particular situation, nowhere else. It tends to be pretty labor intensive as well because you're building everything from scratch. Or you're having to go find modules that you need to build this system. How do we cobble this all together? Support is whoever built the system, or you're not reaching out to a third-party company to help you. And then managing this thing over time, not like project management, but just managing your software can be tedious and tiresome. Basically, if you build something yourself, you have to be able to maintain that for its lifetime, right? Not necessarily a bad thing if that's what you want, but it's a concern. All right, solution number 2. I use that term middleware. We have some application in the middle of our setup. Now, we're basically going to kind of take the idea of building it ourselves and bring in this custom thing that's going to help us out. Now, if you have ever done any network programming or dealt with any applications where you have a distributed type of setup, you might have seen some of these acronyms. So remote procedure calls, Corba, DCOM. Never played with Java RMI, but I assume it's for this kind of a setup. So basically, we're going to take some, again, middleware for handling traffic and directing it, and we're going to bake it into our applications. We're going to bring in this Corba module. All right, vendor specific. So any other systems that want to plug and play need to support this middleware as well. The greater internet, we're very heterogeneous on the internet. There's lots of different systems out there. It's probably not going to work too well. And it's also been found that scaling these systems tends to be a problem as well. They don't really do well with a massive amount of users. It can be optimized to handle a lot of users, but it's not natively, useful. So then the other solution is let's use the web. And when I say let's use the web, let's use some of these technologies that are being developed to handle websites, to handle all of these web applications that are out there. Let's take that and use it for our own purposes. So let's take the concepts of HTTP. Let's use XML to package things up, or JSON, as we'll be seeing in a little bit. But basically, why not use this distributed web platform for our own purposes? Again, we can translate all this to whatever internal application we're building here. Or if you're building a web application, it's already native, right? So the idea here is that we're going to not care whatsoever who is using our platform, who is accessing our systems and services. We're agnostic. It doesn't matter. We are just packaging up based on these well-known standards. And if your system can read these standards, there's nothing stopping you from using our service. Scalability is possible as long as we manage it appropriately. And when we say that, basically, can our servers handle X number of hits? Do we have a distributed load processing setup if we get too many people accessing? Slightly different concerns, but things to be considering. But if we are using these well-known standards, ideally, others can play in our pool as well. Other concern would be security. So if we start talking about opening again, this theoretical internal application up to the web, well, we need to handle authentication and authorization. If it's just internal, hopefully we can get by with whatever security measures are inside of our systems, maybe tie that to Active Directory or LDAP or any of our user authentication systems on the sysadmin side. But if I'm exposing my service to the greater internet, anybody can access it. What you're going to see in one of the demos that I've got, let me see if I still have it open or not. But we're going to be defining some cloud functions. All right. And this is a service that we can provide where, here I'm providing a random dad joke. This is just a URL. Anybody can access it. I don't need to be logged into Google. I don't need to be logged into my GVSU account. Anybody with a network connection could access this thing. For the purposes of this little demo, it's fine. I don't care. But if you had some sensitive data, that could be a problem. Alrighty, so just to kind of round this bit off, so I'll split these videos up a bit just based on timing. But I want you to consider how much the internet and the web has evolved over time. Now, I found this really awesome web history generator, and it seems to be down right now at least. But it generates an SVG graphic of all of the new technologies that are being developed for the web and how it's being used. And it's really, really interesting. The key takeaway, I mean, obviously it's a very messy image without any context. Here we see XML HTTP requests to, kind of in here, we see touch events. We see CSS3, which doesn't reapply other than for styling, obviously. We see file system APIs, IndexedDBs, geolocations. Basically, here are all of the technologies that we can use to interact with other services. If I have a system where I need to handle files, before I'd probably need to use FTP or some kind of a technology where it's going to be really annoying for me to handle things, or I can use a file system, right? The idea is that as the web kind of evolves, the more capabilities it presents, the more we can do with our web applications. And again, these are all standardized, nice things that we can use. And if you build an application where you adhere to these standards, it's going to be very extensible and reusable. One thing I want to leave you with before I round out or end this video, let's say you build a web application and you follow these, these standards that we've been talking about, whether it's HTTP, JSON, XML, whatever you use. Okay, I build this thing today. I can take that code and reuse it 2 years down the line, assuming, nothing has drastically changed. And, maybe a couple updates, but it should still be fine. It's following these well-known standards. Contrast that with, I built a VB.NET web application and it works great, but it only works for a particular version of Windows Server. It only handles the .NET 3.5 framework and. If I want to update it, it's a massive slog to handle compatibility updates and things of that nature. Maybe even the networking protocols changed, I'm not sure. But if you're following well-known standards, it should be a lot more maintainable and extensible. Okay, I will end this video now and we'll pick up next time. Bye, everybody.